Okay, let's take a look at our last two problems from section 9.4. In one case we're adding areas, in the other case we're subtracting areas. So we'll begin with number 60. What we have is a figure that is made up of other figures or basic geometric figures. We have a triangle, we have a rectangle, and we have a parallelogram. So our measures, we have the height of the triangle is 9. The base of the triangle, also the side of the rectangle, is 10. The other side of the rectangle is 4. And the height of the parallelogram is 3. So what we want to know is we want to know the total area of the figure. So here's what you need to do on these. You want to divide it up into the basic pieces. We have a triangle, we have a rectangle, and we have a parallelogram. So that's 1/2 base times height. So in this case it'll be 0.5 times 10 times 9, which would be 45. Okay, our rectangle, the area is base times height. So we have 10, or length times width, I guess actually. 10 times 4, which would be 40. And the parallelogram is the base times the height. Notice the base is the 10. Both of those would be 10. So it's going to be 0.5 times 10 times 3, which would be, I believe, 15. Okay, and so we want to add these together, and we're going to get 10, and I'm getting 8, 9, 10. Okay, they have 115. Did I copy a number wrong? 4, 3. All right, 1/2 base times height. That's correct. I got 45, because that would be a 5 times a 9 would be 45, so that one's okay. Base times the length times the width would be 10 times 4, so that one's correct. And I know what's wrong. That shouldn't be a half. That should just be, got carried away there. Okay, so 5. Okay, so we're getting 115. I really goofed that one up. Okay, so we found the error. Base times height. No half on that one. All right, our other example, number 68, comes from subtracting. We're going to end up subtracting areas, and I wanted to do one with circles. Okay, we have 2 circles within the larger circle. And the radius of one of these circles is 4 centimeters. So we have 2 circles within a circle, and the shaded part, let me use my, if I can get my highlighter. The shaded part is the part of the large circle that's outside the smaller circles. And I'm not doing a very good job of coloring this morning. There we go. Okay, so we're looking for the shaded area. So what we need is the area of the large circle, and then the area of the 2 small circles. And we'll have to subtract them, and that'll give us the shaded area. So the first thing we have to do is kind of imagine that we extend this to get a radius for the large circle, it's going to be 4 plus another 4. So the large circle, the radius is 8. So for both the smaller circles, they appear to be the same size. So this one would also have a radius of 4. You more or less have to take that, figure that out for yourself. So let's get the area of the large circle. That's going to be pi r squared, and they tell us to use 3.14. So our area, I've misplaced, here's my calculator, 3.14 times my 8 squared, which is 64, gives me 200.96. Okay, let's work with the small ones down here. We know the radius is 4, and so the area of 1 would be pi r squared, which is 3.14 times 4 squared, which would be 3.14 times 4 squared would be 1650.24. And we have 2 of them, so I need to double that. Times 2 is 100.48. So I need to take the area of the 2 small circles and subtract that from the area of the large circle. So I'm going to get 100.48. So the thing we want to learn from this is that if we're working with figures that don't look like our usual figures, if we can break them down into our usual figures, our regular geometric figures, we can still work with the problems and come up with the answers.